Alright, chapter 7, lesson 5. Number 1, we're supposed to factor each of the following integers into primes and then write the integer as a product of its prime factors using exponents when there are repeated prime factors. Okay, so I'm going to do A, E, and I. Okay, so I like to start with the factor tree no matter how small it is, just to keep it consistent. Alright, so 6, I know I can always divide an even number by 2, so that's always what I'm going to start with. Alright, and then 2 is a prime number, 3 is a prime number, and I will usually circle anytime I get to a prime number just to remind myself that I'm done. Okay, so 6 equals 2 times 3. Alright, 36. Alright, it's an even number, which means 2 is always divisible. 36 divided by 2 gives me 18. It's still an even number, so I can choose 2 again. Alright, and as I go along, I'm going to circle the number just to confirm that it's a prime number. So 2 times 9 will give me 18. Alright, 9, it's not a prime number yet because we can split that into 3 times 3. 3 is a prime number, going to circle, all numbers are circled. I have 2 times 2 times 3 times 3. Now remember it says to use exponents, so that is 2 squared times 3 squared. Alright, the next one is a little harder because it's a bigger number. Alright, now you can use your divisibility rules to help narrow down or quickly find out what are possible factors. Alright, so this number is ending with a 5, so I should recognize that it's divisible by 5. Alright, so 5 is a possible factor. Now to find out what the other factor is, I would need to use long division. And I'm going to just work it out here. Alright, that'll give me 245. Alright, I'm going to circle 5 because it's a prime number. Now 245, I can again divide it by 5. Alright, that's a prime number. And now I'll have to find out what that is. Alright, that is 49. Now 49, by using my times table, or it can go back to the divisibility rules, I should be able to figure out that that is 7 times 7. Alright, and 7's a prime number, so I can go in and circle those, and that means that 1225 equals 5 times 5 times 7 times 7, which equals to 5 squared times 7 squared. Okay, so just remember to use your divisibility rules to help you narrow down which factor it is, or else you'll just have to check each one by one, which will take a lot longer. Alright, I'm going to skip over number 2 because the answer key explains it pretty well. Alright, so I'm going to move on to number 4. Alright, we are to factor 350, and then we're actually given some choices to see which is the best answer. Alright, now the simplest way, or the least complicated way, is just to factor out 350. Alright, so we can go and use the factor tree. Alright, now anytime I have a 0, I would always factor out that 10, alright, instead of factoring out the 2 and having to do that multiple times, because 10 is really easy to factor out to 2 and 5. Right, and that also makes the other factor a number that is a lot smaller, which is more manageable. Alright, so 35, using my times table, I know that's 5 times 7. right? And that leaves me with the prime numbers 2, 5, 5, and 7. Right, so that equals to 2 times 5 times 5 times 7. Write it in exponential form. I get 2 times 5 squared times 7. And looking at the choices, that is choice A. Alright, I'm also going to skip over 6, 7, and 8 because the answer key has a pretty lengthy explanation and I think explains it pretty well. Alright, so hopefully you won't have any troubles there.